Hello, and welcome to another tutorial video for CSCI 2824, Discrete Structures. In class, you've been learning all about rules of inference. We're going to now demonstrate how to do an example rules of inference problem. Here's our example problem. Show that with P and Q, if P then not R, and if Q then not S, that not R and not S is a valid argument. The first thing you're always going to want to do when working with the rules of inference problem is to lay out a neat table. Not only does this make your work easier to read for you, it makes it easier to read for those who are grading you. You want to include the number of your step, the step itself, so this is where we'll be manipulating the above statements with rules of inference, and a justification for each step. Make sure that you split each step into individual parts. Don't combine rules of inference. So the first thing that we want to do is lay out our premises. Our premises are what we're given in the problem. So P and Q, if P, then not R, and if Q, then not S, are all premises. Now that we have our premises in place, we want to move towards working that not R and not S is a valid argument. We'll start with our first premise, P and Q. If it's the case that P and Q is true, then we can say that P must be true. This is a simplification of step one. Why does this make sense? Because with a true statement, in order to get true, we must have true and true. If we had true and false or false and false, we would get false. So now that we know that P is true, we can start to look at the premise, if P, then not R. Because P is true, we know that not R must also be true. This is modus ponens of step 2 and step 4. Again, this makes sense because if P is true, then not R must also be true. If not R was false, this statement would be false. We can use similar logic when working with Q. Again, because of P and Q, we know that Q must be true. This is simplification of 1. And again, similarly, if Q is true, then not S must also be true. And this is modus ponens of 3 and 6. Finally, we can prove that not R and not S is a valid argument. If not R is true and not S is true, it's the case that not R and not S is true. And this is a conjunction of 5 and 7. So, we have essentially used the premises to show that not R and not S is a valid argument. While you may face some rules of inference problems that are longer than this, the format is always the same. Lay out a neat table, write down your premises, and use one valid rule of inference at a time to work towards your conclusion. It's no doubt that you'll get a hang of it in no time. Good luck!